In today's interconnected world, software security is paramount. Software vulnerabilities can have devastating consequences, from data breaches to financial losses. Software quality assurance, or SQA, plays a crucial role in mitigating these risks. Security testing, a critical component of SQA, focuses on identifying and addressing vulnerabilities throughout the software development lifecycle. By proactively addressing security concerns, organizations can protect their assets, reputation, and user trust. Neglecting security testing can lead to costly remediation efforts and irreparable damage to an organization's reputation. Software security testing encompasses various techniques and methodologies designed to uncover weaknesses that malicious actors could exploit. These weaknesses can manifest in different forms, such as design flaws, coding errors, or configuration issues. By identifying these vulnerabilities early in the development process, organizations can reduce the risk of exploitation and minimize potential damage. Security testing is not a one-time event, but an ongoing process that should be integrated into every stage of the software development lifecycle. The importance of software security testing cannot be overstated. As software becomes increasingly complex and interconnected, the attack surface expands, making it more challenging to secure. Organizations must prioritize security testing to ensure that their software is resilient to attacks and that sensitive data is protected. A comprehensive security testing strategy should include a combination of automated and manual testing techniques to provide comprehensive coverage and identify a wide range of vulnerabilities. Moreover, security testing should not be limited to the development phase, but should extend to the deployment and maintenance phases as well. Continuous monitoring and testing are essential to identify and address new vulnerabilities that may emerge over time. By embracing a proactive approach to security testing, organizations can stay ahead of the curve and mitigate the risks associated with software vulnerabilities. In conclusion, software security testing is an indispensable aspect of SQA that is critical for ensuring the confidentiality, integrity, and availability of software systems. Vulnerability assessment is a crucial aspect of software security testing. It involves systematically identifying and quantifying security weaknesses in a software system. This process typically involves automated tools and manual analysis to uncover vulnerabilities that could be exploited by attackers. Vulnerability assessments help organizations gain a comprehensive understanding of their security posture by highlighting areas that require attention. The primary purpose of vulnerability assessment is to identify potential security holes before they can be exploited. By identifying these weaknesses early on, organizations can prioritize remediation efforts and reduce their overall risk exposure. Vulnerability assessments typically involve scanning the target system for known vulnerabilities, such as those listed in public vulnerability databases. They also involve analyzing the system's configuration and code to identify potential misconfigurations or coding errors that could lead to security breaches. The impact of vulnerability assessments is significant, as they provide valuable insights into the security posture of a software system. By identifying and addressing vulnerabilities, organizations can strengthen their defenses and reduce the likelihood of successful attacks. Vulnerability assessments also help organizations comply with industry regulations and standards, such as the Payment Card Industry Data Security Standard or the Health Insurance Portability and Accountability Act. Regular vulnerability assessments are essential for maintaining a strong security posture. As software systems evolve and new threats emerge, it's crucial to conduct periodic assessments to identify and address any emerging vulnerabilities. Organizations should establish a vulnerability management program that outlines the frequency of assessments, the tools and techniques to be used, and the process for remediating identified vulnerabilities. Penetration testing, often called ethical hacking, is another crucial aspect of security testing. It involves simulating real-world attacks to evaluate the effectiveness of a software system's security controls. Unlike vulnerability assessments, which focus on identifying potential weaknesses, penetration testing aims to exploit those weaknesses to determine the actual impact they could have on the system. Penetration testing typically involves a team of skilled security professionals who use a combination of manual and automated techniques to attempt to breach the target system's defenses. These professionals, often referred to as penetration testers or ethical hackers, use their knowledge of hacking methodologies and tools to simulate the actions of malicious actors. They document their findings, including the vulnerabilities exploited, the sensitive data accessed, and the extent of the compromise. The impact of penetration testing is invaluable in assessing the real-world security posture of a software system. By simulating real-world attacks, organizations can gain a realistic understanding of their vulnerabilities and the potential consequences of exploitation. Penetration testing helps identify weaknesses that may not be detected through other security testing methods, such as vulnerability assessments or code reviews. The findings from penetration tests provide actionable insights that organizations can use to improve their security controls and reduce their risk exposure. Penetration testing should be conducted regularly, especially after significant changes to the software system or its environment. Organizations should engage with reputable security firms or independent penetration testers to conduct these tests. The results of penetration tests should be carefully analyzed and used to prioritize remediation efforts. By addressing the vulnerabilities identified through penetration testing, organizations can significantly enhance their security posture and reduce the risk of successful attacks. Software systems are typically composed of multiple layers, each with its unique security considerations. Effective security testing requires a layered approach, addressing the security concerns specific to each layer. This section will delve into the security testing considerations for the network, application, and data layers. The network layer forms the foundation of a software system, providing the communication channels for data transmission. Security testing at this layer focuses on ensuring the confidentiality, integrity, and availability of data in transit. This includes testing for vulnerabilities such as unauthorized access, data interception, and denial of service attacks. Common network security testing techniques include port scanning, vulnerability scanning, and penetration testing. The application layer is where most user interactions occur, making it a prime target for attackers. Security testing at this layer focuses on identifying vulnerabilities in the application's code, logic, and configuration. This includes testing for common web application vulnerabilities such as cross-site scripting, XSS, SQL injection, and authentication bypass. Common application security testing techniques include static analysis, dynamic analysis, and penetration testing. The data layer is responsible for storing and managing sensitive information. Security testing at this layer focuses on ensuring the confidentiality, integrity, and availability of data at rest. This includes testing for vulnerabilities such as unauthorized access, data modification, and data loss. Common data layer security testing techniques include database vulnerability scanning, data encryption testing, and data backup and recovery testing. By adopting a layered approach to security testing, organizations can ensure that their software systems are protected at all levels. This comprehensive approach helps identify and address vulnerabilities across the entire software stack, reducing the risk of successful attacks and protecting sensitive data. Regular security testing across all layers is essential for maintaining a strong security posture and mitigating the evolving threat landscape. Continuous improvement is paramount in software security. As technology evolves and new threats emerge, organizations must adapt their security practices to stay ahead of the curve. Continuous improvement ensures that security measures remain effective and relevant in the face of changing attack vectors. One crucial aspect of continuous improvement is regularly reviewing and updating security policies and procedures. This ensures that security practices align with industry best practices and regulatory requirements. Organizations should also invest in ongoing training and awareness programs for developers and security personnel to keep them updated on the latest security threats and mitigation techniques. Another vital aspect is implementing a robust vulnerability management program. This involves establishing a systematic process for identifying, assessing, and remediating vulnerabilities. Organizations should leverage automated vulnerability scanning tools and conduct regular penetration testing to identify and address weaknesses in their systems. By promptly addressing vulnerabilities, organizations can minimize their exposure to attacks. Continuous improvement also entails fostering a culture of security within the organization. This involves promoting security awareness among all employees and encouraging them to report any suspicious activity. Organizations should establish clear communication channels for reporting and addressing security concerns. By creating a security-conscious culture, organizations can significantly enhance their overall security posture. In conclusion, continuous improvement in security practices is not a one-time effort, but an ongoing process. Organizations must adapt their security measures to address the evolving threat landscape and ensure the confidentiality, integrity, and availability of their systems and data. By embracing a culture of continuous improvement, organizations can stay ahead of the curve and mitigate the risks associated with software vulnerabilities. Remember, security is a journey, not a destination.